Alright, welcome back. This is 6.5, solving linear inequalities using multiplication and dividing. Today we're going to explore what are the changing effects of multiplying and dividing by negative numbers as well as just regular multiplying and dividing. So if we think about our regular inequalities, it means things that are not equal, just like our examples that we have below us, our 8 examples. So if you were to, let's say, add a value to each side, you could do so. Nothing really changes other than just the two numbers. So we have 0 is less than or equal to 7, or if we wanted to, let's say, subtract 2 from each side, we could do that instead of adding. So we have negative 4 is less than or equal to 5, actually equal to 5 to go 2, 3, okay, so on and so forth. So adding and subtracting is not really too much that can change. And I could add 5 to both of these. That's what you should add 5 to both of these. And you could subtract 5 to both of those. Just take a look at what really changes. We want to get to multiplying and dividing. So let's say if I had negative 2 is less than or equal to 5, and then I multiplied this. Multiplied this by 2, and multiplied this by 2. So I have negative 4 is less than or equal to 10. Well, what changes when I multiply by a negative number? This is what's new. When you multiply by a negative number, everything changes the sign. But if you think normally, an equal sign, how can I change that? Well, it doesn't really change. The opposite of an equals is an equals. However, with an inequality, the opposite of less than is now greater than, and vice versa. So in this case here, if I wanted to multiply everything by negative 2, over here and over here, I could go ahead and say, okay, negative 2 times negative 2, that's positive 4. And 5 times 2, that's negative 10. 5 times negative 2 is negative 10. And now, what's the opposite of less than or equal to? Well, it would be greater than equal to. Okay, so that's really the big change that's happening now. So whenever you multiply by a negative number, the inequality flips. Okay, so there is a flip right here. I would strongly recommend you highlight this section here because this is super important. It's one of the keys to success for this unit. Likewise, you could divide by 2. If I divided both sides here by 2, I'm just going to get negative 1 is less than or equal to 2.5. 2 is 2.5. But if I wanted to divide everything by negative 2, both sides, I get 1 is greater than or equal to negative 2.5. Okay? So that everything is a true statement here. But the big key things to realize is if I multiply or if I divide by a negative number, the inequality changes. It is key to recognize that. So let's just take a look at a couple examples here of when we might have to change something like an inequality, when we might not. So if we take a look at these two problems, one of them we have to change, one of them we don't, for an inequality. So we have 6a is less than or equal to negative 18. See how there's no negative in front of the 6? I really don't have to worry here. So I'm going to get a is less than or equal to negative 3. I can verify that by just choosing a number that's less than negative 3, which would be like 6 times negative 4. And let's see if that answer would be less than negative 18. Well, 6 times negative 4, that's negative 24. Negative 24 is less than or equal to negative 18. And this is true because negative 24 is obviously less than this. So where we have a is equal to negative 3, I can go ahead and I can shade in this value here for negative 3. And then I can redo the rest of this line here. So we can values that are less than negative 3. Likewise, with this question here, in front of the variable, I have a coefficient of negative 2. It means I got to divide both sides by negative 2. When you divide both sides by a negative, the sign, it's an inequality, flips, it changes. So I'm going to get n is less than negative 7. What's the number that's less than negative 7? Let's choose negative 8, see if that works to verify. Negative 2 times negative 8, I wonder if that's going to be greater than 14. Let's take a look. Remember, we'll always verify with our original question. So negative 8 times negative 2, and that's 16. 16 is in fact greater than 14. So we're looking for numbers that are less than negative 7. And down here I do have negative 7, negative 8, negative 9. And I'm not going to put in a shaded circle in there because n isn't equal to negative 7. But n is all the values that is less than negative 7. So that's what we have to do there. Moving forward, if we have y over negative 3 is less than negative 1, realize the common trait here. I would have to multiply both sides by negative 3. And so I have to multiply this by negative 3. So that way, y on this side, it's going to go from less than to greater than. Negative 3 times negative 1 is 3. So I'm looking for a value of y that's greater than 3. So I can say, oh, well, 4 over negative 3, that should be less than negative 1. Well, that makes sense because that's negative 1 and 1/3, and that is less than negative 1. So I'm looking for values where y is greater than 3, so I can put that in there. So 3, 4, 5. Y is greater than 3. It's not equal to, so I'm not shading that. And go ahead and shade all of the other values that are going to be greater than 3. Alright, well, what about this one here? X is divided by 7. So what's the opposite of divide by? 7 multiply. So I have to multiply this by 7 and that by 7. So these 7's cross out, meaning x is greater than or equal to 21. I didn't have to make any changes there. Why? Because I didn't have to multiply or divide by a negative number. So I'm looking for a number that's greater than 21. Well, let's say 49. If 49 over 7, is that greater than 3? Well, 49 divided by 7 is 7. So yes, that is greater than 3. So that will work. So x is greater than or equal to 21. I can go ahead and start my number line here below. So I have 20, 21, 22, so on and so forth. Numbers I'm looking for are equal to 21. Okay, so I'm going to shade that in here. And then all the numbers that are greater than 21. There we go. Okay, last two questions. So we have negative 3a subtract 6 is greater than 12. Okay, so this is an extra step here. So I have to first add 6 to each side. So I'm left with negative 3a. The reason why I added 6 was to get rid of this, so this is now gone. So 12 plus 6 is 18. Now I'm going to have to divide by negative 3. Keep in mind, when you divide by negative 3, the sign is going to change. Okay, so the sign is going to be less than rather than greater than. So a is less than 18 divided by negative 3 is negative 6. So we're looking for numbers that are negative 6. You can check and verify this if you have space here. I don't have much space. I would like you to try and check if you can. So let's say -8, -7, and -6. We're looking for numbers where a is less than -6, so we're not going to shade in here, and then we're going to continue this line on for all values. A is less than -6. Okay, and this will be your toughest type of question here. So we have 2.4x plus 3.6 is greater than or equal to -10.8 plus 3.6x. Well, what I will do in this case is I will actually make this harder. I'm going to subtract 2x, or 2.4x to both sides. I'm sorry, I'm not going to do that because that's actually easier. I want to show you that earlier. What I would normally do is I would take away 2.4x and then I would get 1.2x on this side. I wouldn't have to deal with a negative, which is a little bit easier because you don't have to worry about this flipping. But let's subtract 3.6 first. So we'll get the ones on the right side. We'll get the whole numbers on the right side, and then the x's on the left side. So if I subtract 3.6, I should be able to get negative 14.4. Okay, so 10.8 take away 3.6 is negative 14.4. And then I have 2.4x on the left side, plus, don't forget my 3.6x on the right side. So what I'm going to do here is I'm going to go ahead and subtract 3.6x to both sides. So that's what I'm going to get there. And lastly, after I do that, I'm going to get negative 1.2x is greater than or equal to negative 14.4. I'm going to have to divide both sides by negative 1.2 because that's what's in front of x. Now, when I do that, everything changes here with respect to, okay, I'm left with x. Negative 14.4 divided by negative 1.2 is 12, but my sign changes. So x has to be less than or equal to 12. And then I can just verify that solution by plugging in 12 for x on the left side, 12 for x on the right, 12 for x on either side, or a number that's less than 12 to just determine if this case is true. And then lastly, just to graph it, I can do 11, 12, and 13. And then for my graph, just to prove that it's equal to 12, I can put a circle there, and then I can shade along the rest of this line. Don't forget to shade the arrow to show that x is less than or equal to 12. Okay, so that's how you multiply and divide by negative numbers with linear inequalities. So the key thing is, when you multiply or divide by negative numbers, the sign changes, the sign flips. That's the key thing to remember, because if you don't make that change, your entire question will be incorrect and not true.